We input some information in our minds through our senses, process it, and then give some kind of an output with our actions. Well, Java IO is kind of similar in nature. In this chapter, we're going to talk about Java IO, stands for input output, character streams, storing objects in a file, IO hierarchy, and a lot of related topics coming right next.
In this chapter, we're going to talk about Java IO, or input and output. Consider the following example. Let's say you have a water purifying plant, and all you need to do is to take in the water from the river, purify it, and send it to an overhead tank. So we have a river, which would be the source, and we'll have an overhead tank, which will be a destination. Now, in order to take in the water from the river, you need to create a pipeline. And once we install the pipeline, a stream of water will start flowing. This stream is called an input stream. The reason is this stream has become an input source of water to this water purifying plant. Similarly, we need to have another stream between the water purifying plant and the overhead tank, and we need to let the purified water flow in that stream. Now this is called an output stream, because the output that comes out of this plant is going to get transported to the overhead tank. Now do take a note that once we take in all the water inside the river, there's nothing left in river. Similarly, once we transport all the water from the purifying plant, there is nothing left in purifying plant to process. Now keeping this in mind, let's try to map the same example with IO in Java. We can replace this water purifying plant with a Java program, and we can replace this source or the river with a file. There can be any number of sources, but for the sake of this example, let's consider it to be a file, and this file will have some kind of text in it. Similarly, we're going to have a destination, and in this example we're going to consider another file as the destination. Our job is to copy all the text in here to the destination file, and in between we may want to do some processing. But in this example, I just want to demonstrate you how to copy this text from the source to the destination. And for this purpose, we need to create the pipeline or the streams. We're going to need to create an input stream, and to put the data from the program to the destination, we need to create an output stream. That's exactly what I'm going to demonstrate you now. In this case, the stream that's going to flow is bytes of information. Although it's the text which we see on the file, internally it's all zeros and ones. So this stream would constitute bytes of information. Now let's go to Eclipse and see how this can be done. Import this project Java IO, and in that open up this file, Java IO file example. And here the first thing that I'm going to do is to create input stream. Since we're dealing with file, we're going to create the file input stream. And the argument that you're going to pass in is the path to the source file. Let's create a source file. I have already done that. I've created this file todos.txt, and in that I just have a text which is essentially my to-dos. Let's get the path of this file. Let's copy this and paste it over here. And remember, we need to use the escape character, which means another slash, and you're going to provide the name of the file, todos.txt. Let's expand this. Now we have an error here. Can you guess what it is? It's a checked exception. There could be possibility that this file is not existed at all. So we need to either provide try catch block or just use throws. Now we have created the input stream. Now let's create the output stream. Let's copy this statement and paste it over here. Let's call this out. Of course, this has to be file output stream. Let me copy this and paste it over here. And the argument that this is going to take in is the destination file. Let's have a new file name in here, something like that. Now the next thing that we're going to do is to read each and every byte of information from the source file. And for that purpose, we're going to use the method called read inside this class file input stream. While we're also going to be needing an int variable. We'll see why in just a while. I equals in dot read -1. Now what we're trying to do here is the input stream in here is going to have stream of information, and in this case is just bytes of information. The text is essentially represented in bytes in our hard drive, and that's exactly what is going to come inside the stream. The file input stream is going to have the bytes of information of the text inside that file, the source file. And this read method in here is going to read 1 byte at a time. And once it reads 1 byte, it's going to read the next byte the next time we come back to this loop. So we keep looping in this while loop for each and every byte of information. And in here, we want to do something with that byte of information. Also, there has to be a condition to break this loop. The condition in here is when the read method returns -1, that means it has reached the end of file. Going back to our previous example, that means the river has no water to consume. So we'll quit out of this loop. By the way, we seem to have an error here. Again, we're going to provide the throws declaration. We're going to come back and talk about try catch block, how we can make use of it. In fact, this is the perfect place where you will understand the try catch block and even the finally block in better fashion. So we'll get there pretty soon. So for each byte of information, what we want to do, we want to print that or we want to send that information to destination. So we can certainly make use of this output stream. So we're going to say out.write. It's going to take in the integer parameter, and I'm just going to pass in the I. So what does this variable I hold? It's just going to hold the integer form of the byte information. So this read method will read the data as byte and is going to convert that byte information into integer. When we pass that integer to this write method of the output stream, the write method is going to convert, in fact it's going to typecast this integer into character. And how is this done? Going back to our typecasting examples in the beginning of this tutorial, we've talked about how we can typecast an integer to a character. Let's say the value in here is 65. Then if we typecast it to a character, it's going to be capital A. Let's take a look at the ASCII table. You can find this table in ascii.cl, and you can see if the integer that we're going to get is say 90, then that's going to be the letter Z. Similarly for 65, it's going to be capital A or uppercase A. Likewise, we have total of 127 characters. And if you take a look at the extended ASCII table, there will be total of 256 characters. The reason why there are 256 characters is because in each byte there are 8 bits. So within the 8 bits, how many combinations of zeros and ones we can have is 256. Let's go back. When you're going to read each and every byte, and when we convert that each and every byte to int and eventually to a character, it's not going to go beyond the 256 characters, because ultimately we're reading 1 byte at a time. Hope that's clear. And this is pretty much it. This should copy all the contents in the todos.txt to the todos new.txt. Let's save the file and run the program. You probably won't see any console output because we don't have any system.out.println instructions. Let's go to our desktop and see. Here it is. We have exact same information. This is definitely a good start for this chapter. See you in my next video. In this video, we're going to talk about character stream. The example that we talked about in our previous video used the byte stream, meaning the data that we're reading from the text file, we're not reading it in the form of character or text. We're reading it as bytes, just as it gets stored in the computer memory. And internally, we're trying to convert those bytes, etc. But ultimately, this stream, the file input stream, is going to hold the byte information of the text present in the file. And we are looping through each and every byte, and we're trying to do something with it. We can also use the character stream. Instead of the byte stream, we can have character stream so that we can loop through each and every individual character from the text file instead of looping through each and every byte of information. Now you may ask me, how does that make a difference? Consider the following example. Let's say I'm creating a new file in here. Let's call this temp. This file is going to remain here temporarily. And in here, I'm typing in some random text. If I save the file, it saves comfortably. No problems whatsoever. But what if I enter some kind of text that looks something like this? Now if I try to save the file, then we get a prompt saying the file contains characters in Unicode format, which will be lost if you save the file as an ANSI encoded text file. Now what is an ANSI encoded text file? To know more about it, I would recommend you to go to Wikipedia. Here it is. An ANSI character set has no official meaning and has been used to refer the following among other things. So the ASCII character set that we've talked about in our previous video is one of these. So what I'm trying to say here is all these characters in here are not part of the ASCII character set. And the kind of encoding, the default encoding which we're trying to use here does not support these characters. And that's the warning that we're getting. To keep the Unicode information, click cancel below and select one of the Unicode options from the encoding drop-down list. So let's click cancel. Let's save the file. Do you want to replace it? Yes. Okay, and let's close the file. And if you try to open the file now, we're seeing just a bunch of question marks. The reason is the ANSI encoded text does not support the characters that we have put in here. So it just doesn't know what to put in here, so it just shown us a bunch of question marks. Now let's do something different. Let's have the same special characters and save the file. We get the same warning. Click cancel, but this time we're going to use a different encoding, UDF-8. Let's save the file. So I want to replace it. Now if I close the file and reopen the file, it's going to retain those characters. That's the magic of the encoding. So what has actually happened here? If you understand, for each and every byte, there are only 256 combinations of zeros and ones, and all the characters inside the ASCII character set would occupy all those 256 characters. It's not possible to represent any of these characters in just 1 byte of data. So if we use the UTF-8 character encoding, each one of these characters is going to be represented in more than 1 byte. It's going to be between 1 to 4 bytes. Now let's close this file. Let's go back to our example. In here, let's try to read from the text file, the temp file with all the special characters. For the sake of this example, let's get rid of the output stream. Instead, we're just going to use the sysout statement, and we're going to print. And all I want to print here is the integer value that we're going to get, and I'm going to append it with character representation of that integer. Now let's try to run the program. What has just happened? Can you guess? Although we have only 4 characters in that text file, why are we getting so many characters? The reason is, as I mentioned, each one of the characters in the text file is no longer 1 byte. It could be 1 to 4 bytes. And we're just looping through all the byte information in here. So to represent all those 4 characters, there are a total of 11 bytes. Now this is clearly a problem. The characters which we have in the text file were not getting printed in here. That's because we're converting each and every individual byte information to character, and we're trying to print. The solution to this problem is read the content inside this text file as individual characters, not as individual bytes. So how do we do that? We're going to use the input stream reader, and let's call it INR, input stream reader, and new input stream reader, and the argument that we're going to give is the file input stream object. Essentially, this is going to act like a wrapper for this class, meaning this is going to convert all those bytes of information into characters. But still we have one problem. By default, this is going to use the default encoding. What is the default encoding? If you right click on this file, go to properties, and in here you see the default encoding. The text file encoding is of CP1252. Let's click cancel. So what we're going to need to do is we're going to have to tell the kind of encoding it needs to use while converting the bytes of information into characters. And you can pass in another argument to the constructor of input stream reader, and you're going to say UTF-8 format. Now let's try to run the program. This is still going to cause a problem. Obviously we need to use the input stream reader object in here, not the file input stream. And this is going to result in going through each and individual character, not bytes. Pretty well and good. Ignore this first character. This is called BOM, or byte order mark. This is used for holding the information about the bytes that are getting stored, etc. It's a little tricky there, but we're not interested in this. All we're interested in here is the rest of the characters, which are 4 characters. But still we didn't see the characters in here. That's because this console in here is not using the UTF-8 encoding. So we need to change that as well. We go to properties and choose other, and in here you can choose UTF-8, click OK, and then let's run the program you would see all those characters. Pretty well and good. Similarly, for file output stream, we can have the output stream output stream writer, and you can specify the kind of encoding. Let's try to do the same. I'm going to uncomment it. Let's copy this line and let's call this OSW, output stream writer. It's just plain opposite of input stream reader, output stream writer. And obviously we need to send the output stream object to this, and we're going to use the same to print all those characters using the write method. And we send the integer as an argument, which in this case is I. Let's save the file, but this time let's use a different file name, temp underscore new. But before running this program, we need to use another method inside the output stream writer, which is flush. So what this method will do is it will flush all the characters that are in the stream, output stream writer, to be written into the destination file. We'll see and we'll talk about this pretty soon. Let's run the file. There it is. Pretty well and good. Now instead of creating all this mess, let's comment this out. You can simply use file reader and file writer objects like so. File reader, you're going to have exact same constructor. Obviously this has to be changed to file reader. Similarly, we can have file writer, and you can use file reader to read the information and file writer to write the information. Now, how is file reader and file writer is different from file input stream and file output stream? The file reader is going to use the character stream, not the byte stream, by default. But whereas in here, we need to use a wrapper class, which is input stream reader, to be able to read bytes of information as characters. But there is one problem here. The file reader and file writer is going to use the default encoding of your operating system, and most of the operating system may not support the UTF-8 as the default encoding. So it's not recommended really that you use file reader and file writer. Instead, use this mechanism. Now obviously this program is going to result in inappropriate results because it's going to use the operating system's default encoding. So let's undo everything. So that's it for this video. Thanks for watching. See you in my next video. In this video, we're going to talk about buffer reader. Buffer reader is used for the sake of efficiency. Let me give you a real-time example. Let's say you have a river with some water, and let's say there is some kind of a pipeline connected to that river. In one end of the pipeline, there is a tap that will control the flow of water. If you turn off this tap, the flow will stop. If you turn it on, the water will start flowing. And let's say your house is located in some remote location where there is no supply of water. Let's also assume that you only have one container which is of capacity 1 liter. Let's say the distance between these two is say 10 kilometers. Now every time you need water, you need to walk for 10 kilometers, collect the water of 1 liter and come back. This is a very tedious job. So instead of doing it in this manner, you would rather purchase a container of say 50 liters. You would take that container to the location where the water is available, fill that container and get it back and pour it on your overhead tank. Now this way you're getting a lot of water in one go. So you don't have to go 50 times to get 50 liters of water. Now this is exactly what we can achieve with buffered reader. So far, when you read the data using input stream reader or file input stream using the read method, you're fetching data all the way from the hard disk. In comparison with this example, with our Java example, we can replace this river with our file inside the hard disk, and the tab can be replaced with the input stream that we create, and the house can be replaced with our Java program. So if you use the read method of either input stream reader or the file input stream, every call of this method is going to fetch data from the hard disk. So each and every character, if this is a character stream, then for every character we need to go all the way to the hard disk and get that character to our program. This is very expensive process. Also, if you remember, in one of our previous videos, I've explained that we will make use of the native interfaces, and we actually take help from the operating system to get access to the files inside the hard disk. And that's a very expensive process. So instead, if we use the buffered reader, instead of getting one character at a time, it's going to get one chunk of characters in one go and is going to store in the RAM memory. In this example, it's the overhead tank. Once we have a chunk of data, not all the data by the way, just a chunk of data in the RAM memory, with our program it's very easy to access the data and it's very faster. And when we are accessing this method, the buffering mechanism is going to refill this buffer with next stream of data. We can also set the size of this buffer. Now let's go back to our program and see how we can make use of the buffered reader. Alright, here we are. All we're going to need to do is to create an object of the buffered reader. I'll do control space to autocomplete. Let's call it BR, stands for buffer reader, and equals new, again control space, buffer reader. And the kind of argument that the constructor of the buffer reader would expect is an object of the character stream. In here, this is the file input stream, and we have wrapped this input stream with input stream reader that will make this stream the character stream. So this is exactly what we're going to pass as an argument to the buffer reader. Let's get rid of all this code in here, or maybe just I would comment this out for your future reference. And in here I'm going to create a variable of string. We'll see why in a minute. And I'll call this line. I'm also going to have a while loop, and inside the while loop I'm going to do line equals, I'm going to use the buffer reader object dot, now see the magic. We got a method called readLine. The readLine method will help us read data from a file line by line. And once this method returns null, that means there is nothing left to be read from the buffer. Let's just do sysout, and we're going to simply print that line. Let's run the program. By the way, let's change this back to to-dos. And in here, we don't have to have the UTF-8 encoding anymore, because all the characters inside this to-dos.txt will belong to ASCII character set. Let's run the program. Pretty good. We also have buffered input stream. And this class will help us use the buffering feature for the byte stream. So in here, it cannot take the character stream, it will take the byte stream. You're going to have to use a different method in here. br.read and is going to return an integer. So I and similarly -1. We will print that integer and we convert that back to char. Let's run this program. Now obviously, since we used the println method, it's going to print a character along with the new line character. Let's get rid of this and use the print method. Pretty well and good. Just remember one thing is that it's always better to use the character stream when you're dealing with the textual data. Since todo.txt is holding the textual information, let's undo the changes and use bufferedReader. Now you may wonder, when do we ever use file input stream? I mean the byte stream. If you're dealing with an image file or a music file or a video file, it's better that you use, or in fact, you have to use the byte stream, not the character stream. It's only when you have to deal with the characters you should use the character stream. And no matter which stream you use, always make use of the buffering mechanism, and that will improve the performance dramatically. Alright, that's it for this video. Oh, wait a minute. I guess I have one more thing to say. Just as we used bufferedReader for input character stream, we can have bufferedWriter for character output stream. Let's do that and have a complete example. So we're going to have the file output stream out equals new file output stream. Let's copy this argument. To-dos, let's call this buffered output, and we're going to have to convert this byte stream into the character stream. Output stream writer new output stream writer, and we're going to pass in the byte stream object. And finally, we're going to have bufferedWriter new bufferedWriter, and we pass output stream writer object, which is a character stream, character output stream. And now we can just simply use this bufferedWriter to write the data into the file. Let's save the file and run the program. Let's go to desktop, and here it is. Well, that's funny. I guess we have to flush the data. Let's do that. bufferedWriter dot flush. This is what will actually dump all the data into the file. Let's save it and run the program. Here it is. You may ask me why we have everything under one line. It's not actually having everything under one line. Basically, the readLine method will actually omit the new line character. If you take a look at the Java docs and see the description of what the new line method would return, this is what it says. A string containing the contents of the line, not including the line termination character, or null if the end of the stream has been reached. And that's why we got everything under single line. Now going back to our example, we can always increase the size of the buffer. You just have to provide another argument. The default size of the buffer used by the buffer reader is 8192 characters. However, we can configure the size of the buffer to any size we want. So all you have to do to increase the buffer size is to send in another argument to the constructor. Basically the amount of bytes of buffer you would need. And always keep in mind, as a good practice, instead of typing in some number, try to type in the multiples of 1024, because it makes 1024 bytes to make 1 KB of memory. And if you give multiples of 8, that means we're going to have the buffer of size 8 KB. The program will run just as before. Let's close the file and reopen it. Pretty well and good. Alright, that's it for this video. Thanks for watching. In this video, we're going to talk about closing the streams. Once you're done using the streams, it's always important that you close the stream. To explain you in better fashion, I'm going to make use of the functionality provided by the Eclipse, which is debugging. Debugging will allow you to pause the program while the program is running, and it will let you analyze the code then and there. So, to make use of the debugger, we need to have some breakpoints. For example, if I have a breakpoint in here, and when we run the program using the debugger, the program execution is going to pause in here for us to do something. Let me just show you. So instead of running the program, I'm going to click this bug icon to start the debug process, and the controller will stop right there. It won't process further until we say it to go. So in here, you can just analyze this line. So the line currently is holding this text. If you press F6, it's going to move on to next instruction. By the way, I have moved out the code of buffer reader and buffer writer under another file, which is bufferreaderwriter.java. And I've also have a new line introduced right after each and every line. So the output will now have a new line character. Each line will be printed in a new line. Now moving on. So you can analyze the code like so. And if you click resume, the controller will stop at the next breakpoint. If there is no breakpoint on its way, it's just going to complete the execution of the program. So let's click this, and since we are in while loop, it's going to stop here again, but this time the line is different. I hope you got the purpose of the debugger. Anyway, why am I explaining this? To tell you the significance of closing the streams. We have this output stream open. That means we didn't use any statement like close or something to close the stream. Now let's see what can happen if you don't close the stream. If I go here and if I try to delete this file, I'm going to get a message saying the action can't be completed because the file is open in Java platform SC binary, which means some Java process is using this file, and so we cannot delete it. This is a very simple program, and we may not see any damage being done, but think of very large applications where there could be thousands of Java files, and when you run that application, and let's say you have opened a stream and you forgot to close it, then throughout the execution of that entire application, you cannot do anything with that file. And that's why I've used the debugger in here to stop the program, making sure that the stream is still open. And as we've looked at, we cannot delete the file. So what we need to do is we need to use the method inside the buffer writer called close. Let's stop the program to close the stream. Buffer writer dot close. Now there are a couple of things that's going to happen with this. One is you no longer need to use the flush keyword, because when you close the stream, it's going to automatically flush the data onto the destination. In this case, it's another text file. Number two, if you close the buffered writer stream, it's also going to close all the corresponding streams, which are output stream writer, file output stream as well. And it's also important that we close the input stream just like so, using the close method. Now this way we're ensuring that we didn't keep the file stream open throughout the execution of the entire application. Let's run the program, and everything works just as before. Now another reason why you want to close the streams is from operating system perspective. When you create an output stream or an input stream, you're essentially opening a file to do something with it. And even in your operating system, you cannot just open unlimited number of files. There is a certain limit. If you keep opening files, hundreds and thousands, over time you will reach to a point where you won't be able to open any more files. Same with this. If you keep creating the streams and not closing them, ultimately in larger applications it's going to result in reaching the limit of the files, and the rest of the program may not be able to create streams or deal with files. Now that's a big problem. So always remember to close the streams the moment you're done with it. If you don't close the stream manually, the Java is going to take care of it, but there will be a very big delay, because when the garbage collector comes in and destroys this object, that's when the stream will get closed. And we're not sure when the garbage collector will come, and definitely we don't want to rely on it. We still have one more problem in here. Can you guess? Well, I'll give you a clue. Is there any possibility that these instructions will not get executed? Sure. If you have an exception in these lines, then this is not going to get executed. What is the solution? Use try catch finally block. So let's get rid of throws in here, and instead let's wrap the entire code inside the try catch block, surround with try catch block. Eclipse has automatically did the job for me. We have an error here. We'll get there what it is, but we're leaving the scope for these instructions to not get executed. For example, if we have a written statement in here, this won't get executed. So what is the solution? We're going to have the finally block, and we're going to have these two instructions in here. Now let's see what the error says. There is one checked exception. So for that we need to provide another try catch inside the finally block. And even for this, the code is really getting bigger due to introducing the exception handling, but it's really worth it, believe me. We have one more error. Let's see what it is. It just says the variable is not initialized. This has to be initialized to some value. In this case, let's make this a null. Because the initialization happened inside the try block. By the way, what if this BR is a null? Then this is going to throw a null pointer exception, and since the exception is not handled in here, this statement will not get executed. Serious problem, right? So as a good practice, it's always better that you check to see if this object is null. If it is not null, then go ahead and close the stream. So it's going to be if not equals null, then you'll do this. Same in here. PW, and let's save the file. In fact, now you can have these two handled under one try catch block. No problem whatsoever. Let's save the file. Let's do Ctrl+Shift+F to give proper indentation. And there it is. This is a proper way of dealing with streams. And the reason why I said you need to have this variable initialized is because you can't just use a simple reference type without that reference type pointing to certain object. We cannot call the method close without pointing it to some object. And that's why when you get rid of this in here, it's going to show us, the compiler is going to tell us to initialize the variable. Alright, that's it for now. See you in my next video. In this video, we're going to talk about how we can make use of Java IO package
to copy an image file. By the way, all these classes we've talked about were all part of the package called java.io. We're going to talk about all the classes, and in fact we're going to go through the hierarchy of classes inside this package pretty soon. In this example, since we're dealing with an image file, we don't need to use input stream reader. Input stream reader is specially meant for textual stream. So we can simply get rid of this. Let's save the file. Now all I'm doing here is I gave the path of the picture, which in this case is mypic.jpg. Let's go there and take a look at that picture. So this is mypic.jpg. Well, the name is mypic, but this is not me inside the picture. Just that the picture is mine, but I'm not the one who is inside it. Anyway, we're going to copy this image using the output stream. Again, this is file output stream, and we have the exact code as to that of the one we have seen in our first example. Let's run the program and we should see a copy of this image with the name mypiccopy.jpg. Here it is. Here is a wonderful picture from India. Let's close the file. Alright, now what I want you to take away from this example is that using the file input stream and file output stream, you not only deal with textual data, you also deal with pictures, music, video files, etc. Now what this also explains is that if you were to develop a software or an application like Photoshop or Audacity to edit the audio files, etc., this is what you're going to do. You will make use of the byte stream and you will do something with it. Hope that makes sense. See you in my next video. So far in our examples, we've used files as source and destination, and for that purpose we've created file input streams and file output streams. But there are multiple types of source and destinations. In this example, we're going to use array as a source and array as destination, and for that purpose we're going to have to create a stream that has something to do with array. In this case, we have a byte array, and you need to enter some values within the range of byte, which is -127 to 128. If you enter something greater than that, for example 129, it's going to show us an error saying the mismatch cannot convert from int to byte. Let's undo, and we've created byte array input stream, and we pass this array to the constructor of this class. So essentially what this means is this stream in here is going to read bytes of information from this source, which in this case is an array, and all I'm doing here is just looping through each and every byte, trying to convert each and every byte of information to character, and I'm just printing it. If you run this program, you would see character representation of all these bytes in this array. And just as we've used file output stream to create an output stream for file as a destination, we can have an array as a destination, and we can use byte array output stream to create the stream between the program and the destination. In this case it's another byte array, and instead of writing it to the console, I'm just going to write it to this array. And all I'm doing in rest of the code is I'm actually converting that output stream to an array, and I'm kind of assigning it to this byte array, and I'm looping through each and every element of it, of this array, and I'm printing it in the form of character. Let's run this program. There it is. Alternatively, you can use a string and you can convert that into array of bytes by using the method getBytes of the string class. Let's save the file and run the program. Pretty well and good. On the contrary, if you're dealing with the character array, then you can use the char array reader to create a character stream between the program and the character array, and you can do something with it. And obviously you can have char array writer to write the data into an array.
Just remember, when we have the stream at the end of these class names, then that means we're dealing with the bytes. If we have a reader or a writer, then that means we're dealing with the character stream. Okay, pretty well and good. Let's run this program. There it is. See you in my next video. It is possible that we store an object along with its state into a file, and then again from another program we can get that object back again along with its state from that file. Well, this might sound confusing, but it is possible. And for that purpose, we're going to have to use a mechanism called serialization. What is serialization? A serialization is a mechanism where an object can be converted into a byte stream. And in order to be able to convert an object into a byte stream or to be serializable, the class has to implement this serializable interface. Only then the objects of this class will qualify to be serializable. In this class, this is a very simple class where we have one constructor and we are setting the state of one of these variables in here by sending an argument to this constructor. In this case it's color, and we're going to use this method to get what we have set in here. We also have a method, and that just simply going to show this message barking. What I did in this file is I have created an object of that class and I had set the state to brown. The color of that dog is going to be brown. And the next thing that I'm going to do is going to create a file output stream. We're going to use file output stream to put all the binary data of the object into a text file. And in order to convert the object into the binary data, we're going to have to use this class object output stream, and its constructor will take in this object, the object of file output stream. And using this object, we're going to call this method write object, and we're going to send the object that we want to serialize as an argument to this method. Doing so, the object along with its state will be converted into a binary form and will be stored inside this text file. And finally, we're going to close the stream. By the way, in our examples, we're not using the try-catch block. The example that I've demonstrated you is definitely not a good practice. You're going to have to use the try-catch block. It's just that the number of lines of code will increase if I introduce try-catch blocks. Let me show you how the class looks with try-catch blocks. Here it is. This has increased the lines of code almost doubled. Anyway, let's run this program and we should have this file created. So here it is. Let's see what's inside it. You would not understand anything. Well, basically the text editor, Windows text editor, tried to convert all those binary data into characters, and this is how it ended up. But what you're seeing is essentially the dog object in a textual format. Isn't that wonderful? Now let's go back. I have another program which is object input stream, and as you would guess, we're going to create an object input stream to read the object binary data back into the program, and then we can use that object along with its state. So in here, that's exactly what I did. Using file input stream, I'm reading the data from the file, and then I'm sending this as a parameter to the constructor of object input stream. And using this object, I'm going to just call the method inside it, which is read object, and I need to typecast it back to the desired object. This is dog object, so here is the class name. And now we can call the method inside it, as well as we can also get the state that we had set when we serialized the object. So what we have done here is we have deserialized that object, and we're able to play with that object. Let me run this program. Awesome. Isn't that wonderful? The concept of serialization and deserialization will come into picture when we talk about Java 2 Enterprise Edition, where you would deal with web applications, etc. But it's a long way ahead. I'm just trying to tell you the significance of using the streams for dealing with objects. Hope that makes sense. See you in my next video.
We've been using streams throughout our examples even before this chapter. And those streams are something that we didn't create. Those were created by the Java virtual machine. I'm talking about system.in, system.out, and system.error. Let's talk about system.in. System.in is a stream that is connected to one source. The default source of system.in would be your keyboard. So whenever you have this defined system.in, then you're actually doing something with your keyboard. This will let you enter something from your keyboard while your program is running. Now I said system.in is an input stream, but is also a source. It is a source to this object, the scanner. We could use input stream reader, but the problem with that is we would only be able to enter one character at a time. But whereas if we use scanner, you can enter a bunch of characters, string. So hence I use this scanner, and using this scanner I'm going to invoke the method inside it, which is next line. This will let me enter the value when the program is running. Similarly, we're taking another input, which is the last name. Let's talk about system.out. It's an output stream, and the default destination for this stream is going to be your console. And that's why whenever you use this statement system.out.println and you provide something inside it, you would say something on your console. The system.error is no different from system.out, except there is some formatting done that will make the text look like an error. Whenever we get an exception, we see red colored text on our console. Internally, it had used system.error to display that text. Even when you're creating a custom exception, it's always advisable that you use system.error instead of system.out. Now let's run the program. I'm going to enter the first name and last name, and we have the output. Now do take a note that when we had used system.error, the text is actually highlighted in red. Alright, see you in my next video. In this video, I'm going to talk about the file class. The file class will allow you to access the underlying file system. In this particular example, all I'm trying to do is I'm trying to see if this file is existed. If not, I'm creating one and displaying some details about it. For that, I have an object of the file class, and I'm going to pass in the path of that directory as an argument. Do take a note that this path can either be the path of the directory or the path of any specific file. Let's make sure in our desktop there is no directory with this name. Now let's run the program. So file is created. In this case, it's a directory with the name subdirectory, because that's what we gave in here, and we've displayed the absolute path of the directory. Let's go to desktop. Here it is. So this method makeDirs not only created the directory but also the subdirectory. In our previous examples, whenever we had used input streams, we're passing an argument. Although this looks like we're passing a string, internally this string will be converted into this file object. So this line in here is internally like this. The new file object and then the path. I've just demonstrated a very simple example, but you can explore more such methods inside the file class. For example, if you do new dir dot, you got a lot of methods to explore. We have isDirectory method to check to see if the path given is of a directory or a file. You can actually go through the description in here. Similarly, we have the delete method. This will allow us to delete the file or the directory. There are many such methods, and I would encourage you to go and explore and play with it. Alright, see you in my next video.
Alright, let's look at the class hierarchy of the Java IO package. It's quite a large package with lots of classes, but we've covered all the major classes that are in here. Also, more than anything, the point I want you to take away from this chapter is, depending on the source and destination, you need to choose the stream. For example, we've used file input stream when we are dealing with files. We've used byte array input stream to read the data from the array. And we've used object input stream to deal with objects. It's impossible to talk about each and every class in the Java IO package, but we've talked majority of them, and I'm sure by now you are capable of understanding the purpose of rest of the classes in here. All you have to do is to click one of these classes and see the description. And some of these are also having examples associated. If you look at this hierarchy, the ultimate parent of all these classes is the object class. Console is something that will let you enter values from the console. This is somewhat similar to the scanner example we've seen in our example. We've talked about file, and we've talked about some of these classes in the input stream. We've talked about the object streams, and we've talked about output stream classes, for example, byte array output stream, file output stream, etc. And coming to permissions, basically using these classes, you can deal with the permissions that you give to the file or the folder. It's pretty self-explanatory if you read the description. The random access file is something that will allow you to read the data somewhere in the middle of the file. And we've talked about readers. We've talked about the writer. Basically, readers and writers will deal with the character stream, whereas when you have input stream or output stream, all these classes that end with stream will actually deal with the byte stream. And we are aware of some of these exceptions, and they're all child classes of throwable, and that's very obvious. I guess we've covered majority of these classes, but we might be missing some classes here and there, which is fine. And in fact, some of these classes will be covered at later chapter. For example, talking about the piped input stream is something that you'll understand when we talk about the multi-threading concept, which will be our next chapter. Also, I'll try to put examples of some of these classes in the project files along with the description, just for the completeness. So I guess that's it. This will summarize this chapter, and we'll definitely be using streams throughout our course. And in fact, when we get into Java to Enterprise Edition, we definitely have to use streams in order to get our job done. So until then, stay tuned.
I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles, and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.